Welcome to Walkabout the Galaxy, the conversational astronomy podcast where the science is universal, the opinions are personal, and the guests are international. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney,
coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram, and soon, TikTok.
Oh, this is going to be awesome.
We are also on www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. Contact us anytime at wtg@ucf.edu. Today, we are delighted to welcome Dr. Hannah Sargeant of UCF, an expert in space resources, or in situ resource utilization, usually called ISRU. ISRU. Mm-hmm. Hannah is currently working on ways to get oxygen out of moon rocks. Hannah, welcome to Walkabout the Galaxy.
Thank you very much. It's a pleasure to be here.
Yeah, lovely to have you. Our stumper today is temporal. So we usually start the podcast off with a stupid question of my devising for Jim and Addie. So I'll give it to them, and then you can take a crack at it yourself. Our stumper is you are going on a 1-year time travel adventure. You can take whatever you want with you, but you're stuck there for a year. You have no escape during that time. You're going to return automatically after a year. When do you go?
Yeah, I really expected the question to be, what do you take with you?
Well, that depends on... You can tell me what you're going to take.
Buddy also?
No.
Oh, just me.
Just you.
You can take a what, but not a who. But you could take a Winnebago if you wanted to.
All right.
But depends, what. So what do you think? Past or future?
You can go first. I'm going to go past.
Which past?
So
you got to be more precise than that.
It would be super cool to go to the future, but it's way more unknown.
Yes.
So and it might just be really depressing, and then you get back to your normal time, and you're like, "Oh,
why am I even bothering?"
Yeah. And then you just,
nothing to live for.
And then you just sell all your things and live in a Winnebago and travel the world or something. So maybe it works out in the end.
Maybe you stop worrying about.
Yeah.
I know how it's all going to turn out. It's going to be fine, or it's going to be a mess.
Sure.
So you don't need to worry about it one way or the other.
Because there's nothing you're going to be able to do about it.
So how far back are you going to go, though?
Not too far back. I don't know. So I always when I was little, I really liked the sort of early settlers kind of time frame.
Really?
When it was cabins and stuff like that.
So you're going North America, 1800s?
Yeah.
Okay.
Just for maybe a year's a little long. 6 months would be okay.
Yeah.
But I think I'm going to do it.
You have to go a year.
Okay.
I'm going to go for a year.
On the western half of the continent?
Or the Midwest.
Midwest.
Yeah, I was
where you're
from the
from.
Midwest, so that's probably what I was.
So you're going St. Louis,
Little House on the Prairie
1850.
kind of crap.
Interesting. Yeah. Jim, what about you?
I've decided I'm going to the year 1006.
Ooh. Okay.
Okay. What happened that year?
He doesn't know.
Trivia question part 1. What happened in 1006? So for one, part 1, let you answer in a second. Part 1 is I hate people. You know what I'm saying?
Are
Now, I like
there are places,
people.
Yeah.
There are places.
Are all great.
Thanks.
Present company accepted.
No, I like individual people, but I don't like lots of people. I get really upset. It's kind of like what Eddie said. If I was from the past and came to the future, I'd be like, damn it, there are no wild places
too many
left on Earth.
people.
Every nice place there is to go, it's just swarmed with people.
Right.
So in the 1006,
unless you're
that's
in
not
Canada.
the case.
Already right now, we're at the limit for you in this room.
Oh, yeah. This is about as many people as I can deal with. So, 1006.
What was that?
I'll move down the desk.
All right.
Hannah, you're great. Addie, Josh, even Diego over there.
Even Diego.
Everybody's great, but I don't like a lot of people. So 1006 would be great. You could wander around the North America, and there'd just be almost nobody. There are some few people, I suppose, back then.
There were some people,
and they natives, but
and lots of buffalo.
Before that.
Buffalo, all kinds of things. Woolly mammoths,
Right.
Were they? That's what I was wondering.
I think
woolly
they were.
mammoths in 1006? No.
No, they were way.
No.
That.
Woolly mammoths?
They died out at the end of the last ice age.
Which was
10,000 years ago.
Okay, right, yeah.
I'll believe it.
Yeah.
I'll believe it.
I thought you were quizzing me, but you were actually asking.
I was a genuine question.
Okay.
I only know the future.
Okay, all right. Is that Crab Nebula supernova?
So the 1006 was the brightest at least supposed. It's obviously hard to tell.
Sure.
But the brightest thing that's astronomically happened since kind of the dawn of man.
Okay.
Is this
You
the
could take
Chinese
a telescope with you.
Is this the Chinese observations?
Well, there's a bunch.
Yeah,
there were
was
observations from around the world, Japanese and Chinese and Iranian and a whole bunch of places observed. And I know it's something like -7.5 magnitude thing. So like
That's bright.
way brighter than Venus, less bright than the full moon.
Stupid
but
magnitude system.
But really bright, and it would be awesome. And we've been waiting for Betelgeuse to go for the whole time the podcast has been on. But
that's more than 100 times brighter. That's like 300 times brighter than the brightest star.
And you could take observation stuff with you, and then you'd bring it back, and you'd have all the actual observations.
It'd be awesome.
Of it.
We keep waiting for it. I mean, supernovas are supposed to go off in our galaxy about every 100 years, but one hasn't happened since like 1600.
So, okay, so
that'd be awesome.
Why don't you just go to 1600?
How long was it visible? Like, are you
3
there?
months-ish.
3 months. Okay. And then you just have 9 months of trying to stay alive.
Yeah. I mean, I want to see it before, and then I want to see it go off, and then I want to see it, and then I want to just hang out in the wilderness.
In your Winnebago with your food.
Yeah.
That far back sounds like such hard work. There's so
that's
little convenience.
I kind of want a Walden Pond type of thing. Just go out in the woods and live deliberately for a while.
You'll be fine.
Oh,
Okay.
Great.
That sounds like a nightmare to me. When would you go, Hannah?
Not that far back. I like my conveniences.
You can go
Yes.
forward.
I thought about forward, but then, like what you said, it looks like it could be. There's potential for it to be pretty bad in the future. I'm not quite ready for that, or the risk of that. So,
And this past was just a walk in the park.
well, and then I was struggling to find a place in the past because, like, the further back you go, especially as a woman, it's not as easy to do things for a whole year without being frustrated and held back.
Frustrated is an understatement, probably.
So I was thinking maybe the Apollo 11, 1969, for
the
that period
60s.
of time. Yeah, because
Oh, that was a fun time.
because everyone,
I remember.
especially in this industry and working on things related to the moon, there's so much of this nostalgia and throwback to the moon launch. And there was this time when everyone around the world was united, which is a novel thing that I've never experienced. So it would be really nice to kind of experience that for that period of time.
Okay.
Good answer.
Like
Yeah, that sounds exciting. I don't know.
Like that. You like hers the best.
I do, yeah. And I am the only person here who actually does remember that.
Only barely,
I'm sorry
though.
to say. It is true.
Mostly from
It's a
photographs.
faint, dim memory. Well, today we'll talk about the decay of neutrons, new measurements of enigmatic bursts of radiation using the world's largest telescope, and rocks big and small falling from space, plus other asteroidal and lunar space news. But first, this episode of Walkabout the Galaxy is brought to you by the Phanerozoic Eon. Periods and eras come and go, but if you want to be sure to capture all the action, go no further than the Phanerozoic Eon. Starting with a Cambrian explosion, but definitely not going out with a whimper, the Phanerozoic Eon has everything from the first formation of animal fossils to the extinction of the dinosaurs and the development of podcasts. At a mere 541 million years old, the Phanerozoic Eon is just getting started, so make your travel plans for the Phanerozoic Eon with stops at the Cambrian Cafe, the Devonian Diner, the Permian Palisades, Paleogene Blue Jeans, and Silurian Silverware. The Phanerozoic Eon, it takes a licking and keeps on ticking.
For a second, never mind. I was going to make an obscure reference to
Because otherwise, it's
you
good.
were naming all the alliterative
Well, it's good
things.
you didn't make an obscure reference because we don't do obscure
When
in
you
this
were naming all the
podcast.
alliterative things, it made me think of Legends of the Hidden Temple and all the teams on Legends of the Hidden Temple.
It's obscure to me anyway.
Yeah.
Maybe not to
Not
some of our listeners,
people
but
of my generation.
yeah. It takes a licking and keeps on ticking. That's an easy one.
That is an easy one. And I am blanking
Yes.
on it.
What is it?
No.
You don't know?
Nope.
Hannah, you don't know?
It's
It's not Energizer. That's the bunny.
Duracell?
No.
it's not a battery.
Battery?
It's not a battery. What's the it has to do with our Stumper and our sponsor. Both had to do with
Oh, it's a time machine?
it has to do with time.
We can buy
I
one.
forget what it is.
It's Timex.
Oh, that's right.
Oh.
Cheapers.
I knew it was a clock thing, but then I was blanking on all clock manufacturers.
Right. Yeah.
Omega, there's one. Time
That is one.
Okay.
Yep, Timex. So tomorrow morning, before the crack of dawn, is the launch of the Lucy mission. Are you going to see that?
I will be heading to the beach to be watching it from there.
Okay.
Yeah, I'm excited.
Will this be your first witness of a launch?
Kind of. I watched the SpaceX Inspiration 4 from a car driving onto the highway, and it was super impressive.
Yeah. Where was that car?
I was driving away from a Frisbee match in Orlando.
So many questions. So you were in Orlando.
I was in Orlando, yes.
Okay.
So it's way cooler up closer.
That's what I've heard. So, it's going to be an early start. I think it's, 5:30 a.m.?
Yes.
But worth it. And I'm, excited.
Yeah. Are you, either of you going?
I'm going to go into my yard and watch it.
Yeah, Jim?
Yeah, I'm going to set my alarm for 5:30, get up, watch, go back to sleep. Yeah. It's going to be awesome, though.
I'm heading
Even from
I'm
here,
not
but it'll
fancy
be really
enough
cool from
to have
the coast.
passes to go see it. So.
I have a fancy pass, so I'm leaving at 2:30 in the morning.
Oh my gosh.
Yeah, with my
Nice.
fancy pass.
Are you because you go out to Kennedy and then you get on a bus to go to a certain launch
Yes.
site? Yeah.
Yep.
That's the only problem with those things is you have to go like many extra hours early to
right.
get on the bus to go out to the site to watch, and then you just stick around afterwards.
Yeah, I'm even concerned that 2:30 may not be early enough. But anyway, looking forward to it. And Lucy, we've talked about frequently on the show, is an exciting mission because it's going to asteroids, the Trojan asteroids. Indeed. On the way, it is passing by a main belt asteroid. Do you remember the name? Donald Johanson.
That's right.
And do you remember who Donald Johanson is?
Don Johnson.
These are harking back to some of our past trivia questions. So Donald Johanson, do you know, Hannah, who Donald Johanson was?
Should I?
He was in Miami
No,
Vice.
not particularly. No.
Okay, right.
Yeah.
No, I do not.
Yeah, you don't need to feel bad for missing any of the stupid questions on this show.
We don't feel bad.
Right? Yeah. So the
He
Lucy,
was
you know
one
what?
of the discoverers of the Lucy fossils, I think.
Right.
Okay.
Good memory.
Right. Yes.
Nice.
So I do know
I
the Lucy
also am an
fossils,
anthropologist on the side.
Yeah,
so.
I think he's the person who came up with the name Lucy, and I should remember all the details of that because that actually was a trivia, which was why did he name it Lucy, after which Lucy was Lucy named? But Lucy the mission is named after Lucy the fossil.
Yeah.
So he'll be at the launch.
Wow.
Donald Johanson.
Oh, really?
They named, so they're planning the mission. They have a trajectory that happens to come reasonably close to a main belt asteroid. So they pick up an ordinary asteroid on the way to the Trojan asteroids, which share Jupiter's orbit. And so when that asteroid became the target, that's when they had the International Astronomical Union name it after Donald Johanson. Otherwise, it would have been a remarkable coincidence.
Of course, yeah.
That makes a lot more sense now.
Yes.
It does.
Yeah.
Oh, that's nice.
So we had some other space news that was fun for the Trekkies in the room this week.
Yeah, I was like, we did. It's been a really long week. Sorry.
Yeah, William Shatner set a record for
Bill.
The oldest person to go to space, or at least above the Kármán line.
I was wrong. He did not die.
No.
He lived. He made it.
I was concerned. Do you know what? If you're going to go at 90,
what a way to go.
what a way.
Yeah. Oh, yeah.
Yeah.
Oh, yeah. Don't get me wrong. Yeah, that was awesome.
No, he did well. It was interesting, too, watching. They've only released some short clips watching him. So he went up on the Blue Origin New Shepard vehicle. It was their second launch with crew aboard. And the other folks on board were two people who had paid to go, two paying customers, and then one woman who is a part of Blue. And so she was comped a flight.
I'm assuming. And I'm not clear whether or not Shatner
He did not pay.
Yeah.
Mm-hmm. He was asked
He was a publicity.
Yes. But it was really
But I think it paid off for Blue Origin.
Too. Because it was really interesting watching because like everybody else up there was like flipping around and doing stuff and he was just like looking out the window and just being like,
Yep.
what is going on? Kind of thing. Like I don't think he's even done like a 0G flight before.
Right.
I got the impression that he'd never felt that before.
Yeah.
I think they have it's like a few days of training just how not to,
not to mess
run
things
into
up.
each other and press buttons.
Kick each other in the head.
Yeah, when I was out there last time, everybody else went on a tour and they included the astronaut training stuff that they do this time.
Oh.
And there's like a simulator, and so I heard about it, but I was working on the experiment.
Yeah.
But there's like a simulator that gives you sort of the sights and sounds, so you know what you're going to experience and when that's all going to happen in the sequence. But it's not like they do anything.
Right.
So
and they don't. They don't need training.
Yeah. But it would be, but some people, like, I think some of the other guys have probably done some of the, like, flight
parabolic
training,
flights.
Parabolic flights, or maybe the centrifuge or something.
But it's pretty, it's not a super challenging environment. The G forces are into your chest, which are the easiest to take, and they're not super high. I wasn't worried about Shatner. I mean, I've seen him in person, and he looks remarkably fit for a 90-year-old.
He looks like he's 70.
He looks like a 70-year-old. Yeah. It's amazing.
But even the impact on landing, you can see all the dust flying up. Like, I wouldn't.
I think that looks worse than it is.
Because if you look at the speeds, it looks way worse than.
Some of that dust is kicked up because right before they touch down, they fire this burst of gas to soften it a little bit.
I was just imagining his bones taking that force.
Well, what I found most interesting, I actually haven't seen the footage of him in the capsule yet, but what I found most interesting was the right after he gets out. And everybody's like popping champagne and woohoo, woohoo, woohoo. And he was very surprised by the experience. And I was a little bit, I have to say, he's, sort of a jokey kind of guy. And I was a little bit worried that he was going to be making stupid jokes afterwards, but he was clearly very moved by the experience. And the aspect of it that he found most impressive was, like you were saying, everybody else like enjoying weightlessness. And he's like, holy crap, the atmosphere is this thin.
Right.
And that's what I think.
Down there right now.
I think if we got politicians, don't put Bill Shatner up there, put Mitch McConnell up there. Have people who are dealing with climate legislation see how tenuous the atmosphere is.
I've heard that. Like, every astronaut comes back and is like a rabid environmentalist after that because they realize how fragile the friggin' thing is.
And that was Shatner's whole thing. Is like, here's life and there's death, and you're from life to death
we wish
in
it was
an
that
instant.
easy.
Right. So that was an interesting...
It was very interesting. I didn't... anyway. Yep.
Yeah.
And then... I don't know. That was it.
So then it fell back down to Earth, which is my awkward segue to talk about the story I think you posted.
Falling to Earth?
Yes.
Jim sent it to us.
In Canada.
Because it was freaking amazing.
Which, I should have used Canada as a segue because Shatner is from Canada.
Oh. I hope he does a spoken word thing about it because he just released a new spoken word album. So I hope he does another one about it.
Yeah.
But yeah, I didn't really look too deeply into this, but like apparently some woman got like inches from being hit by a meteorite that crashed through her house. Somewhere in Canada.
Which is so rare.
That's insane. Yeah, that's. I mean, like, obviously the Earth gets peppered by stuff every single day.
Yeah.
But the chances of a thing actually hitting a person are some ludicrously small number, and it almost happened.
Right.
I guess she didn't get injured at all, had not a scratch on her or anything like that, but it was in her bed.
Yeah, it landed.
I don't think there has been an impact yet that's
hit a person. There was one in the 50s where it hit it was a similar thing, landed in the bedroom and bounced into her, and I've seen bruised her.
Yeah, the pictures
bruised
of her. The
by
bruise
meteorite.
is horrific. Like her entire torso is black and blue.
Yeah, but not a direct impact. Yeah.
There's a famous picture of one landing on a car, and the car is all indented and smashed. But generally not going to hit people. Or things.
Most of the stuff that hits is
ocean,
doesn't really even make it to the surface in a...
There was the Winchcombe meteorite in the UK very recently, and it hit someone's driveway. And they've actually recently just carved out like a square meter.
There.
Well, they've carved out a square meter, and I think they've got it in like a local museum or something. Like this because it's this big black splatter across the driveway.
That's awesome.
The meteorite did not survive.
No, it did.
Parts of it did.
Parts of it did, but nearby there were a lot of fields, and a lot of my sort of friends and colleagues had been meteorite hunting.
Oh yeah.
But then they had to do the is it a meteorite or is it sheep poo?
Test. That's exciting.
Yeah, because they looked very similar.
I like it. Yeah, this one I was a little suspicious of her story. She was like, she woke up and her dog was barking or something, and there had been a loud noise, and then she found it between two pillows. I was like, okay, sure you did.
Yeah, but I think there's a hole in the ceiling, and also she called 911.
Yeah,
and thought somebody's throwing rocks around my house.
The Hulk is throwing rocks around my house.
Yeah.
I guess there's a construction site nearby, so they did ask, like, were you throwing up rocks last night?
Setting off explosions for some reason. So that's exciting. Speaking about big things hitting the Earth, there was another story about the Tunguska impactor you're familiar with, which was 1908 over Siberia, very remote location. So it didn't really get studied up close and in depth for some years afterwards. Very difficult to get to. And I think that it's miserable with biting insects and things like that. Yeah. But there was no crater. There's just these flattened trees, and they radiate away from some central location. And so we've been, I think the current theory, or the leading theory, has been that it was an object which did not survive passage through the atmosphere and delivered all of its energy in a sort of airburst event.
Right. It exploded up there, maybe because of rapidly expanding gases, because it was a comet. That's kind of the story that I've always told intro classes.
Yeah, I mean, I think that even if you don't have those rapidly expanding gases, an object comes in and it basically delivers its energy at the point where it's the path that it has traversed has about the same mass as the thing that it's gone through. And so the atmosphere is a barrier, right? And so it smacks in and it can hit the atmosphere and deposit all its energy there, or if it has enough energy, it makes it through the atmosphere into the surface. And I guess this new story, they were saying, well, there's some sketchy eyewitness accounts that described...
eyewitness accounts are.
That I was going to say pre-photographic, but it wasn't really pre-photographic. But there was obviously no pictures.
There were no dash cams.
There were no dash cams that described the path of light from the fireball in some way that they could estimate how far really, like how long this thing was in the atmosphere. And their models say that an icy object could not survive passage through the atmosphere for that distance. So they're suggesting that it was
not
actually
pure ice. Did they know that?
Yeah.
Okay.
So they're suggesting that it's an iron asteroid, a small iron asteroid that missed.
Skimmed.
Yeah.
It skipped off.
Yeah, that went through
It's like such a well-defined center.
Yeah.
So it came in enough that it like created the airburst, and then it kept going.
Yeah.
I don't like that.
Yeah, I'm not a huge fan either.
What about it just disintegrating just enough right at the right time, just before impact? No?
I mean, that's what most models have it do.
Yeah.
Yeah. It's like it breaks up in an airburst event and it disintegrates.
Yeah.
But so this new model thinks it's an iron asteroid that skipped off.
It posits that it's an iron asteroid that just missed. But talk about, the long odds of the meteorite hitting somebody on the head. The odds of a big asteroid, big, this thing's still smallish, but sort of stadium-sized object coming through the atmosphere enough so that it does this boom event and creates this gigantic shockwave, but still makes it on through and travels off in interplanetary space.
Would have been 656 feet wide, 200 meters.
The object. Yeah. So, I don't know. It's an interesting idea, and it's maybe will require some further study. That's my space news. Do you have any other space news?
No.
Yeah. You have some space news, though, Hannah, because I forgot to mention that what you're working on here at UCF, alert listeners may have detected that you don't have a Florida accent.
What? Not yet. There's plenty of time. So I'm from the UK, and I've just come here from the Open University, doing moon research, particularly space resources, and how we can use those resources to support missions on the moon, to Mars.
Extracting useful things from those pesky moon rocks.
Yeah, because it's a lot to bring everything we need from Earth.
Right.
So we can't be an interplanetary species and keep coming home every weekend to collect our food and water and fuel.
So college students then.
Right.
Yeah, so we're trying to use what we can. The moon might look like a ball of rock, not that useful, but there's plenty there.
Okay.
Lots of useful stuff.
Uh-huh.
So, the first time I heard about ISRU, I'm like, that's crazy. That'll never work.
Really?
Like, yeah. What did I know?
I'm with you, Jeff. That's
So it's like
I still kind of think that.
Really?
I know that's not true.
Big bucketfuls of moon dirt into some machine, and then out the other end comes like water or oxygen and hydrogen.
Yeah.
We do crazier things here on Earth all the time.
Well,
I would say.
I'm sure. I know we do
Strip
crazier
mining,
things.
All sorts of crazy, industrial processing. I was reading about how we make bamboo fabric last night.
That also, I don't really believe it's bamboo, even though I have bamboo fabric things.
I'll tell you all about it after the podcast.
Okay.
But so we're actually working with the mining
So you're
industry.
one of these people who does the impossible thing of squeezing rocks and having water.
Really strong.
I threw that rock into the house. It was all me.
Now.
Okay.
So I was working with the Prosper instrument back at the Open University, which will be heading to the moon, searching for water and whatnot. And we've shown that we can use that instrument to heat it up, heat up lunar soils, add some hydrogen, and out pops a little bit of water. And we tested that on Apollo soils. So we've literally made water from rocks and soils that Neil Armstrong collected.
Making water a euphemism for what?
Not in the UK, but maybe it's a good job you've told me, so now I can avoid saying that.
I think it might be for like.
What do you do for a living? I make water.
Oh no! Right, yes. Can I retire now?
Yeah. That's awesome. And there was a news item you were mentioning about speaking of the moon.
Yeah, so there was a recent mission, a Chinese mission to the lunar surface. They're effectively practicing this automated landing on the moon, collect samples and return home in preparation for sending humans. Mm-hmm. And as part of that, they collected a sample, one of the first samples in a really long time. And there's been a bunch of analysis done on that.
As somebody who, as I mentioned earlier, witnessed the first moon landing, I would say it was first sample in a really long time. First sample.
Yeah, really long time.
In a normal, modest amount of time.
Yeah, a while. Considering all the other things we've done.
So what's interesting about this sample besides it being the newest sample?
So they went to what they thought was going to be the youngest sort of surface material on the surface of the moon, and they were right. It's the young age of 2 billion years old.
Oh, wow.
Which in moon terms is young.
Right.
Yeah.
Not much has been going on in the moon.
Mm-hmm.
Construction shut down ages ago.
Yeah, so it's so everyone's pretty excited about it, and it's kind of reassuring when samples match this orbital kind of sensing. So we're doing something right. That is a good point, because we think we know all this stuff from our analyses of these remote sensing observations, but then to get ground truth, so to speak.
Yeah, most sort of dating that we do of trying to figure out how old things are on the moon is relative. So you say like, well, this thing is older than this thing, or this thing is younger than this thing. So you can get an approximate age, but that's exciting.
Well, speaking of the Chinese, our first science topic has to do with the Chinese telescope, but before we get to that, I'm going to tell you our trivia, which also is tied more to what we've just been talking about. It's William Shatner-inspired trivia.
Yes.
Ooh. So we now know William Shatner's the oldest person at 90 to have gone above the Kármán line. So here I have some Shatner / Captain Kirk trivia for you. Are you a Trekkie by any chance, Hannah? By the reaction.
No.
By your reaction, I'm very discouraged for your chances on that.
I can feign enthusiation.
Oh.
We don't have answers. It's fine.
Yeah.
That's what we do.
Luke Skywalker? No.
Sorry.
No, I know I won't do that.
What personal item did William Shatner auction to raise money for the charity Habitat for Humanity? It's multiple choice.
Okay.
Was it A, dentures, B, a hair plug, C, a kidney stone, D, earwax, or E, his appendix?
Why is it any of these?
What is going on here?
This is why I was so reassured and joyfully confident to see his very sincere, moving reaction to his flight into space, because it's a guy who has previously
done one of these things,
auctioned off one of those 5 things. So I thought he rose to the occasion of his flight into space. That's your first one. Your second one is Captain Kirk, in case you didn't know, Hannah, especially in the original series, which is a product of the 60s, which, as you mentioned, in the time travel thing.
See, I need to go back and watch it, obviously.
You do. Well, if you go back to the 69, then you can watch it. It'll still be in reruns at that point. You'll have to go back to 68 or earlier to catch it in first run. But as you were mentioning, in picking times to go back to in the past, hard to find a time when you wouldn't run into obstacles as a woman. And in the original series, had a lot of maybe antiquated notions and dramatic things. One of which was Kirk was a real womanizer. That's my very long and winded way of saying Kirk was a womanizer. How many women did Kirk womanize? So, yeah, that's your second question. No multiple choice on that one. But I'll tell you,
in the series or
in the series.
Movies?
Star
Can you
Trek,
tell me how many episodes there were of Star Trek, the original?
Yeah, depending on how you count, there were 79.
Okay.
Should I take a first guess on that
one?
We'll without context from you
sure.
both?
Right now.
I'll wait.
Later. Yep.
And then your last one will be what is William Shatner's favorite episode? So we'll come back to that one at the end of the
Has he never watched it?
Shatner?
Yeah.
He has.
I think he hasn't watched them very much, though.
Maybe not.
I will say he did an interview with Anderson Cooper earlier this week before the flight, and he's pretty amusing. And also, Anderson Cooper has an adorable giggle.
Oh yeah, is it as adorable as Jim Cooney's? Let's find out.
Oh, it's hard to say. That's a hard one to say. They're very different.
Yeah, Penas.
It's very different. This is much higher pitched. You should do a side by side.
I'm just referring to the journal
today.
Oh yes,
Proceedings of the National.
That's exactly what I thought.
Yes. Mm-hmm. PNAS.
We cover. We have articles from them that we talk about.
Yes.
Yeah. The article, the supernova article that won the Nobel Prize and all that stuff, the accelerating universe, that was Penas.
Yep.
And you said it with a straight face.
I did.
Oh, barely.
All right. Let's do it barely. It was a struggle. Let's talk about fast radio bursts.
Oh. So we're talking about neutrons.
Furbies.
Oh, neutrons. Furbies.
You want to talk about neutrons first?
Oh, yeah, that's what he said first. Yeah.
Just because
we've talked about Furbies a bunch in the podcast. Just because they're this thing that we don't understand, and it's fun to talk about things that we don't well understand.
And we're very good at that.
Yes.
Yeah. We especially are very good at that. But these are great because not only do we not have any idea what the hell's going on, but the community in general doesn't either. These are like millisecond or sub-millisecond bursts of radio light that are ludicrously powerful. So it's like the amount of energy released by the sun in a day, in a millisecond or something like that, or in a week. So you know who's doing an awesome job of observing those?
The Chinese.
The Chinese. The biggest...
Fast.
So I don't know. Do you want to call this the biggest telescope in the world?
Yes.
Well, are you going to start going all Event Horizon Telescope on
No,
us?
No, I don't know.
I think yes. You want to call it that?
So it's tough to define these things.
You want to call ALMA the biggest telescope?
No, I want to call Rattan 600 the biggest telescope.
I don't know what that is.
I've never heard of that one.
Really?
I thought that was a line of porch furniture.
It is not.
It doubles as the biggest telescope.
I've never heard of that telescope.
Transforms.
Is that an interferometry telescope?
No, it's a single dish telescope, but it's not filled in.
Where
it's a ring. It's in Russia.
I've never heard
of this telescope.
And you've never mentioned it before.
Well, it doesn't come up very often.
Is it an annular telescope?
It's a parabolic telescope. Except
is it a lenticular telescope?
You're making fun of me. I got that now. It's just a big ring, but it's instead of the whole thing being filled in. So it has the angular resolution of a 600-meter telescope.
But not the sensitivity.
Because only the outermost ring has
I've never heard of that, so we're not going to count it.
Okay, but anyway, in any event.
That's how it works.
Yeah.
This one,
exactly how it works.
FAST telescope in China, what does FAST stand for?
500 meter is the F. Yeah. Aperture spherical radio telescope.
I thought this was a weird name because it's not spherical.
It's not
parabolic.
It's got a parabolic, right? Yeah.
Which is weird. Why they would call it. Anyway, that's the biggest filled in full thing that really looks like and seems like a regular radio telescope. Yeah. But because it's so huge, it can collect a huge amount of radio light. It's very, very sensitive. It's drastically more sensitive than Arecibo, which was the next biggest filled in radio telescope at 305 meters or something across. And obviously way, way better than that Rattan 600 thing because it can collect all that light.
It doesn't exist, so.
Yeah. But and another thing about this FAST telescope is actually also awesome because it can look at different things in the sky. Like it's made up of a zillion different small mirrors that can all move, and then they can move the focus thing at the top that is collected so that it can actually look not fully 180 degrees around the sky, but it can move a little bit.
If you're just listening to the pod this time, you should definitely check out the YouTube. We've got a lot of hand motions.
I'm very excited.
This is actually going to be in his TikTok video. So
yeah, I'm working. Bottom Quark and I are working on some beauty quark. Sorry, are working on some interpretive dances for the planets.
But now we have a fast
coming on TikTok.
But now we have a fast.
Diego doesn't believe me. He's laughing. He thinks it's stupid.
No, he's just
it's
really
going to be stupid. Don't worry.
Very excited to see it, and you can follow us on TikTok at astroquarks.
Right, we don't have anything yet, but it's nothing here yet, but it's coming. It's coming.
You can follow to be the first
dances.
To see. Anyway. Fast is a big, and it's multi-dish,
it's awesome. Anyway, one of the cool things, it's seen a lot of cool things. It's found a bunch of pulsars and all these other things, but one of the cool things that it's found is a swarm of fast radio bursts from a single source, like 1,600 radio bursts from a single source.
In a dwarf galaxy.
Some of them only have occurred once, and some of them occur semi-regularly, and some of them occur lots, but not in any... There was like no correlation between the period.
It's not a secret message.
Not a secret message that we can tell.
So it's
maybe
we don't have the cipher yet.
Are they coming from distinguishably different directions?
No, they're coming from all the same direction. This group of 16, so some dwarf galaxy a few billion light years away.
So what does it mean to say some of them are some way and some of them are another? They're all...
Oh, I just meant in general our knowledge of fast radio bursts.
But not this group of
This particular group is just a bunch... It's 1,600 like signals at random frequencies.
Random spacing and time.
Right, random spacing and time, all in the same place.
All in the same direction. And they conclude that... What are they concluding from that?
That it's a single source. That's one source, and that...
Because this was previously known... I mean, in the early days, the FRBs, we haven't known about them for a very long time. And when they were first discovered, they were just like these accidental thing. Hey, I was looking over there, and there was this flash. Right, in radio, and then that's it. And this one in particular that they're looking at, which has a bunch of ones and twos and zeros or something in its name... is the first one, or one of the first ones, where we saw repeating bursts from the same location.
Right.
But the difference here is they have so much more sensitivity that they've seen like 10 or 100 times more.
Right.
And they've also seen them that are like fainter, right? Because it's more sensitive. And so, or like quicker or something like that. They can see different bursts that we wouldn't have been able to see before.
Right. Right. They're spending, a fair amount of the time on that telescope. I mean,
just looking at this
source.
And this one that we'd seen a bunch of stuff before, so we've
seen a bunch of stuff before, but yeah, now they've stared at it for months and seen, like I said, 1,600, sometimes like not repeating, but sometimes with only 30 seconds between, sometimes with much longer time in between. And I think there's like almost two different kinds. Some of them are not very bright and some of them are bright. Of course, even the not very bright
burst energy distribution is bimodal.
Right,
yeah.
so some kind of a dimmer and brighter ones, and so there maybe it's two objects, maybe it's one object doing two different things.
Yeah. And for those statistically inclined, Josh,
yes,
the abstract says the burst energy distribution is bimodal and well characterized by a combination of a log normal function and a generalized Cauchy function.
Okay.
Yeah.
Sexy.
Mm-hmm.
That's what I look for in data. Yep.
In your FRBs. Basically, it's got like two peaks at different energy distributions, and then it's also like they can sort of explain that, but like why?
Why?
If it's a single source, how do you get? And it's like a spinning source, you'd expect one.
It's got to be more regular, also. Yeah.
Something else.
If we're getting into statistics, then I'll also
what have you done?
I'll also mention that the temporal distribution is non-Poissonian.
Oh.
And that's if you have some a Poisson distribution of a time series event would be things where each event is independent of what came before.
Yeah.
Doesn't depend on when the last one was. So like if something needs to recharge, if you have something that like
if it's got a capacitor in it,
and then it has to recharge for a certain period of time, then that next burst would be correlated somehow to the time of the previous one. Mm-hmm. That would be one example of a non-Poissonian distribution.
Mm-hmm. So it's interesting. So I think this will help characterize or limit the number of things that this could be, but I still think we have no good idea. I remember that in the early days of FRBs, the idea was there was more hypotheses about these than there were observations of them. And now we're getting more and more observations. That's gonna start to narrow the number of possible hypotheses, but I still don't think we've narrowed that much.
Well, careful listeners of the show will remember that we've previously been all excited about, we really think FRBs are magnetars.
Right.
Yeah.
And does this...
I think this doesn't necessarily... No, disfavor? I don't think it... I think, if anything, it disfavors it slightly, just because I think they expected more periodicity in the signals if it was...
a magnetar, which is just a highly magnetic pulsar. Highly magnetic, rapidly rotating neutron star.
Right. It still could be, because those things have very complicated magnetic environments, and you could get these bursts when you get weird magnetic phenomenon happening on the surface, and those probably wouldn't be correlated to it, like its spin rotation frequency or something like that, but...
Yeah, I mean,
as far as I know, they haven't ruled out anything with this or highly suggested anything, but that's just because it's fairly new, and so we have to give the theorists some time. Part
of it is based on how much energy is being released in these pulses. Like it would have already required like a huge amount of a magnetar available energy,
right?
And so it's unlikely. I'm skimming this paper very quickly,
right.
And so it's unlikely that it is that sort of at least a certain type of magnetar model that they have,
and
which is a synchrotron maser magnetron model.
That's just fun. That sounds fancy.
SMMM.
The bimodality of the distribution makes it tempting to think that there's, if not two sources, there's two different physical processes going on.
Right.
But as you say, magnetic fields can get all wound up and do complicated things.
They really are. Yeah. They're way more complicated than I would have.
Try to explain the Earth's magnetic field, man.
Right?
Or the sun's.
Yeah.
Yeah, even worse. Okay, interesting.
Crazy.
Well, you were also excited about talking about neutrons, and this would have been a great trivia. And in fact, because we were talking about this, I almost had a lifetime of subatomic particles trivia question.
It was we can save that for next time.
Yeah, it was just going to be...
Can I say one more thing about the FAST article?
Oh, yeah. I know what you're going to say, and I'm super excited about it.
I had shared this article, and Josh was like, I didn't even read the article, but that picture, I was like, what? So anyway, in the picture, so we were reading the Scientific American article, and the picture in it shows the telescope dish, and I didn't read the caption, but it basically has a little balloon in the center of the dish, and the caption talks about that it's just a picture of them doing maintenance on the dish, and it says it has a microgravity device to help them do maintenance, but basically they have a helium balloon that a guy floats on to be able to clean the different panels in
so
the
he's
dish.
What? That's a person in there?
Yeah.
I think is he in it or below it?
What a job.
He's hanging at the bottom of it, because he's cleaning the panels.
How'd you get that job?
That is awesome.
Seems kind of fun.
A microgravity. That's awesome.
I know. A microgravity mechanism. It's just a balloon.
This giant 500-meter radio dish, and
do you think they drive the balloon with a little drone?
And you can't walk on it.
Like, wait! I left my tools. No.
So he's dangling underneath this helium balloon, so that he's just kind of tiptoeing along like a marionette across the surface.
Oh,
of
that
the,
is awesome!
Disc.
Gravity offloading.
Yes. Yeah, that's super cool.
Because you used to be able to walk on the Arecibo panels, I think, to some extent, but they didn't encourage it, but you had to wear special shoes.
As simple as that is, I don't think I would have ever thought of that. I would have had some ridiculously complicated cable system to try and...
like they do with the cameras at football games.
Right.
Or the Olympics, zooming around. Anyway, that's fun.
American football.
And British football, we have the same.
Yeah, the same, sure. Good. Yeah.
Okay.
Neutrons. So here's an amazing thing about
Boring.
Aww.
I'm just kidding.
Poor neutrons. Protons and electrons do get all of the press, but neutrons are actually kind of awesome too.
Which quarks are neutrons?
Ups and downs also.
Yep, that's what I thought.
Yeah, it's all both protons and neutrons, ups and downs, just different set of ups and downs.
Right.
For a neutron, though, neutrons are weird because in an atom, in a nucleus, neutrons are stable things. They'll exist for the lifetime of the universe if they're just sitting there in an atom. But by themselves, they're unstable. And
they're like the opposite of you. They prefer to be around others.
I don't know what they decay into. That's something I absolutely should know.
You absolutely should.
I absolutely should.
I'm going to check it.
Protons and
feel
particles.
I was going to say, I feel like what they do is spit out a negatively charged thing and
a positively charged thing.
And a positively charged thing. So protons are stable, at least as far as we know. But neutrons are not. And I think we amazed Josh just before the program by giving the half-life of a neutron.
They decay into a proton, an electron, and a neutrino.
I was going to say, it's got to be a neutrino, right? Yeah.
Yeah. Because it's a weird time. Like, usually when you think of decay of particles, it's like millionths or trillionths or billionths of a second, something like that, or
really
the age of the universe.
Right.
Like that.
It's either a femtosecond or 10 trillion years.
Right. But this is 15 minutes. So
give or take 5? Like
give or take. Yeah. I mean, so
what's the error bar in that 15 minutes?
It's pretty small now. That's the point of this article, is measuring that lifetime very carefully has been challenging, actually, because what you have to do is you have to get a whole bunch of neutrons and you have to isolate them. And part of the problem is, like, if they are around nuclei, the nuclei will suck them up and then they will be stable and then you're screwed.
Tricksy.
And so you have to do things like get them into a bottle and take that bottle and like cool it.
What kind of bottle?
Yeah,
like Coca-Cola.
Like,
yeah,
sure.
Glass Coke
Any kind of a bottle. They call it a bottle. I don't know. It's just a bottle. But you have to eliminate, you have to make a vacuum in that bottle that's everything except the neutrons. And you have to cool that way, way, way down so that neutrons aren't bouncing off the edges of the bottle and stuff like that. And you trap them with magnetic fields, which sounds challenging because they're neutrally charged, right? And so in physics 1, you can't trap them with a magnetic charge.
That's a bottle.
What? That person's in a bottle?
Yeah.
Is she a neutron?
That's a big bottle.
That's a neutron bottle?
That's a neutron bottle.
Okay.
I think a bottle is a term like a trap. I think it's a bottle.
Right. When I said bottle, I don't...
It's not
it's not like a plastic bottle that you...
She needs a microgravity device.
But...
Anyway, sorry. Neutrons.
Magnets.
Yeah, you can trap them with magnets because they do have a magnetic moment associated with them. And so you can use magnets to trap those suckers. So anyway, the folks at Los Alamos have been playing with this because actually over time there have been a couple different ways of trying to measure the lifetime of a neutron. One is like watch the protons that they turn into and count how many of those there are. One is count how many of the neutrons remain. Yeah. And they don't get quite the same answer. Okay. And that's frustrating. But this newest measurement is the best measurement of the half-life of a neutron, which again is around 15 minutes, but
14.629 minutes with an uncertainty of 0.005 minutes.
That's pretty short. And that's actually important in astronomy. I think we just picked this article because it's a cool physics article, and neutrons are always important in everything physics and astronomy related. But this is actually really important for us in cosmology.
Oh.
Why?
I don't know.
Because
of neutron stars.
Well, if you want to understand the production of atoms in the very early unit, and by atoms, really, I mean nuclei here, and by nuclei, I really just mean
protons.
To build helium and lithium and deuterium from
protons, you need neutrons.
From protons, you need neutrons. Yep. And so understanding the lifetime of neutrons and how quickly they decay before they get trapped into nucleus is really important. So understanding the timeline of events in the early universe is linked to understanding the lifetime of this.
The timeline being 15 minutes.
It's many Planck lengths.
It's way shorter than 15 minutes, but obviously... even if half of them haven't decayed, you want to know how many have.
And it's very...
how old is the universe, or how long does it... No, I can't answer. I can't ask the question, but
There's a great book out there, if you're really nerdy. It's called The First 3 Minutes. By one of those famous physics guys that I can't remember the name of now. But that's about the time. That's when nuclei were made, in the first 3 minutes or so of the universe.
Right. And I mean, the other fascinating aspect of this, not just that these 15 minutes recently deceased... Nobel Prize winner.
Yep.
That this 15 minutes is such a pedestrian human time scale for this cosmologically significant thing to be happening on. And all you got to do is take that neutron and slap it together with a couple of other protons and neutrons, and it's just hunky-dory for
forever.
Yeah, it's weird.
Forever.
That's super weird.
It is weird. Yeah. Neutrons. Funny
Speaking
business.
of weird, our
William Shatner.
Yes. Your first question was, which weird personal item did William Shatner auction off to raise money for Habitat for Humanity? Bonus points if you guessed the amount it went for.
Oh, I thought you were... Okay.
Was it dentures, hair plug, kidney stone, earwax, or appendix?
I want to go kidney stone.
I'm going to go earwax.
I was going to go kidney stone also.
It was the kidney stone.
I feel like done. There was some distant memory in there.
Yeah.
Maybe I am a
Jim just did it because he's...
I did it because I've had kidney stones also.
And you wish you had auctioned them off?
I think they're the least gross of those things.
I think that as well, yeah.
I thought maybe earwax because it's like harking back to Star Trek and like the ear when they put the little bug in the ear.
Oh, no.
but it wasn't.
No. Are you referring to Star Trek 2 and the creature that went in Chekhov's ear?
Yeah.
Yeah. No.
Mm-hmm. Okay.
Yeah.
I was trying to tie it somehow.
Sorry. Yeah. How much do you think it went for?
$16,000.
$1 million.
$70,000.
Jim gets it. $25K.
Okay.
Yeah.
Okay.
Reasonable.
I was in rupees. No.
It would have been so easy for William Shatner to just give $25K to Habitat.
Sure.
Yes.
Probably the cost of the surgery.
Then he could have kept his kidney stone.
Did you keep yours?
No. How many women in the original series did famous womanizer Captain Kirk womanize, and by that I mean kiss on screen?
Different women.
Oh, and different
Not
women.
all kisses are womanizations, but yes.
I know.
I'm with you. I understand.
I
get you.
But it potentially mostly was.
It was.
Just delivering the question with a little flair.
I got you.
79 episodes in the original series. How many different women did Kirk kiss?
29.
Go ahead, Jim.
And have you ever seen any original series Star Trek?
Original? No.
Not a single one?
No.
You've probably seen like clips of them.
She's proud of it.
I've seen maybe
stills.
a 2-second, and I've seen stills.
Right.
And I've heard of the womanizing, but that's the extent of my old school Trekkie knowledge.
Yeah. Okay. Jim.
64.
What?
Ooh. Different.
I can't remember an episode that I've seen where he didn't womanize
that high, Jim. Go 69.
I was going to. But I was like, that's crude. I don't want to be the immature one on this podcast.
I'm going to go 42.
42. Actually, our least educated person on Star Trek comes closest. Only 19.
19.
Oh.
Wow.
Oh.
So it's way overblown.
Well, I was imagining...
That's 1 in 4 episodes, sort of. It's pretty... I think... I'm not 100% sure that there weren't 2 in 1 episode, but I'm 99% sure that's the case.
Yeah, because I was thinking kind of extended timelines of, same woman in different episodes.
They don't do that.
Wow. He quickly moves on.
Pretty standalone.
They're very standalone. There's no story arc thing like we have, in more modern TV. So they were all very standalone. And
does Uhura count as one of those?
She should. I didn't look at the list, but she should. Yeah.
Didn't look at his black
That's the
book.
famous first interracial kiss on American TV.
Yeah, okay, I had heard of that. Yeah.
Finally, what is William Shatner's favorite episode of the original series? Hannah, I'm sure you're going to get
Episode
this
7.
There you go.
City on the Edge of Forever, Trouble with Tribbles, the Enterprise incident, which is the one where he gets disguised as a Romulan. The Devil in the Dark, which is the one with the big lumpy alien that lays eggs of silicon. And
sure.
I can't wait to go watch it.
Where a insane woman swaps bodies with him and tries to take over the Enterprise.
That's a good one.
And therefore Shatner plays himself plays Kirk as though he's been taken over by an insane woman trying to pretend to be Captain Kirk.
Fun acting job.
Yeah. I'm going to go with that one.
Turnabout Intruder.
Yeah.
I'm going silicon rock eggs.
Yeah, you would.
Yeah.
I'm going with my favorite episode, City on the Edge of Forever.
Yeah, that's a good one.
Hannah she's killing it.
Do you know why? Because I read you.
That is the key to getting the trivia.
the only way
it's
I could
all
do
about
that.
the psychology.
Well, on your first episode, you have got my number better than these two. And this is episode number 257 of Walkabout the Galaxy.
Wow.
So
Are there trophies?
maybe you should have been a psychologist instead of a planetary scientist. The Devil in the Dark, although I would have to say, I take it with a grain of salt. And I would want to confirm it because I happen to know that during the filming of that episode, his father died. Oh. And he was on good terms with his father and was very upset by that. And I've heard him tell the story about the filming of that during that time.
Even more like a strange one to pick.
It is, yeah. Well, while it may have felt like a geologic eon, it was just another episode of Walkabout the Galaxy. Write us a review using the shells of dead tortoises and bury it deep underground where it will someday be dug up as a fossil. Be sure to follow us on Facebook and Instagram.
Dark.
Don't kill them. I don't want you killing anything.
Oh, okay.
I don't want you. I want to make this perfectly clear. I don't
save the turtles.
I don't do anything with. I'm very sorry if I've upset anybody.
You have a sentence.
The turtles.
No,
you heard it here. Hashtag save the turtles.
Oh no!
Do you find the turtle shells a lot?
I'm totally editing this out.
Okay.
Don't you dare. You didn't edit it out when I screwed up that galaxy thing.
That was just hilarious.
No, it wasn't.
It was hilarious to everybody. This is just, so I don't mean to, no. Write us a review on a piece of paper. And put it on the bulletin board.
At your local institution.
It's going to be something about fossils because of the fossils in the Phanerozoic era, Eon.
Yes.
Eon.
That sponsored our episode.
Excellent.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel and our TikTok channel, where you can see most at astroquarks, where you can see most of our episodes, some of our bloopers, and all of our music videos on YouTube, not on TikTok, where you can see nothing at the moment. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance provided by Diego Rodriguez. Thank you, Hannah Sargeant, for joining us today.
Thank you so much.
Thanks to our listeners in Milton Keynes, England, and around the world. Stay safe. I'm Josh Caldwell.
I'm Maddie Dove.
And I'm Jim Cooney.
We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Hashtag save the turtles.
The turtles.